Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 17 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 837, new 21 game. Let's read the problem statement. Alice plays the following game loosely based on the card game 21. Alice starts with 0 points and draws numbers while she has less than k points. During each draw, she gains an integer number of points randomly from the range 1 to max points, where max points is an integer. Each draw is independent and the outcomes have equal probabilities. Alice stops drawing numbers when she gets k or more points, right? We have to return the probability that Alice has n or fewer points. Answers within 10 to the power minus 5 of the actual answer are considered accepted. All right, so now here let's understand this problem statement with an example. N is equal to 10, k is equal to 1, and max points is equal to 10, right? Max points is equal to 10 means that we have cards from 1 to 10. So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now k is equal to 1 and n is equal to 10, right? So here Alice starts with 0 points initially, right? Now from all these points, right now I am at 0, right? I am at 0. So I can choose this number, I can choose this number, I can choose this number, this number, this number, any number, right? I can choose any number, right? And n is equal to 10 given to us. So I don't want to cross 10, right? So we have to return the probability that Alice has n or fewer points. N or fewer points. So that simply means I have to calculate P 10, okay, 10 or fewer points, and P9, and same way until where, until when, P1, right? Because we have all these cards, right? P10, P9, P1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have all these cards are there, right? So here probability to select this P1 card is nothing but out of 10 cards I have to choose this one. So I can say 1 divided by 10. This is the probability for this one. Same way 1 by 10 is the probability for this one. Initially I'm at 0 only. Same way 1 by 10 for this one. And for all these cards I have 1 by 10 probability, right? Clear? Now here we have to turn the probability that Alice has n or fewer points. So for P of 10, probability to choose 10 is 1 by 10, right? Same way n or fewer, right? It is saying, so I can get 9 cards also when I'm at 0, right? Because I didn't cross 1 yet. Alice stops drawing numbers when she gets k or more points. Initially I'm 0, but if I just, let's say if I choose 1, then Alice has to stop the play, right? So probability to get 1 is also 1 by 10. Same way she starts with 0, but she directly chooses card number this 2, right? So probability to get 2 is also 1 by 10, and same way probability to get 9 is also 1 by 10, right? So probability to get all these cards is 1 by 10. So here if I do 1 by 10 plus 1 by 10 of all these, so here 10 and here 1 plus 1 plus until all these 10 numbers, right? So what I'm going to get, I'm going to get 10 here, and here I'm going to get 10. So 10 cross each other, right? So I'm going to get 1. Since I have to return the answer in double, right? So I will just simply return this. So Alice gets a single card, then stops playing. So initially she starts with 0 point, so she can choose any card, right? She is at 0 and she didn't cross this k. She didn't reach this k or didn't cross this k. So at 0 she can choose, she has all these options, right? All these options. So we have to return the probability that Alice has n or fewer points. So she can get 1, 2, 3, 4, any. Okay, so that is why this. Clear? Now see this example number 2 here. N is equal to 6, k is equal to 1, max point is equal to 10. So max point is equal to 10 means we have cards from 1 to 10. Clear? Right? So let me use white color pencil. So we have cards from 1 to 10. Right? Now k is equal to 1, but right now she is at 0. Right? We have to find the probability for n or less than n, right? Probability that Alice has n or fewer points. So that simply means we have to find the probability for 6, probability for 5, and until probability for 1, right? Until here. This is what we need to find. So probability to get 6 after 0, if she can directly choose 6, right? So that probability is what, 1 by 10. Probability to get 5 is also 1 by 10, right? Same way probability to get 1 is also 1 by 10, and once she scores 1 or greater than 1, she has to stop, right? only one time she will play, right? And we have to find the probability from n or fewer. So here below 10 and here total 6 ones are there, so 6, so my output is 0.60000, right? Alice gets a single card, then stops. In 6 out of 10 possibilities she is at or below 6 points. So I hope that this is clear, right? So these two are very, very simple examples because my k is just 1, right? So she is only drawing one card every time. But now here if you see example number 3, n is equal to 21, k is equal to 17, max points is equal to 10, right? And this is my output. All right, now here if you see the constant size, k n 0 to 10 per 4, and max points is also from 1 to 10 per 4, right? So now let's discuss this example number 3 in detail, right? So max points to 10, so I can say I have 10 cards. So 1 2 3 4 5 6 7 8 9 10, right? So I have 10 cards. Initially she is starting from 0, right? She is starting from 0 initially, right? Now here if you notice one more thing, we have to stop when we get 17, right? Then we have to stop, and n is equal to 21. So what we need to find, we need to find the probability of that Alice has n or fewer points. So that simply means n means probability of 21, right? Or probability of 20, or probability of 19, or probability of 18, probability of 17, right? Or after this, let's stop it here. Okay, let's stop it here. Why? Let me tell you one reason here. All right, so here when my k was 0, when my score was 0, initially Alice score is 0, and we can only go until here k is equal to 1, right? So we are at 0. 0 is nothing but k minus 1. Here also when we are at k is, when we are at 0, then we have choices of picking any card out of this 10, right? Because max point is equal to 10, right? Here also let's say when you are 16, when you are at 16, when you are at 16, so you can pick a card 1, you can pick a card 2, you can pick a card 3, you can pick a card 4, right? 5 6 7 8 9 10, all these cards you can pick, right? So after 16, if you are going to pick 1, you are going to get 17. If you are going to pick 2, you are going to get 18. Here if you are going to pick 3, then you are going to get 19. Here 20, here 21, right? Here 22, here 23, here 24, and here 25, and here 26. You can go until 26, but in my example number 3 I have to say n is to 21 or fewer than 21. So that simply means that I have to check until here only, right? Because once I reach this 17, after that I don't need to pick any card because I have reached the value of k, right? So here probability to get 17, right? This is what I need to calculate. Probability to get 18, this is what I need to calculate. Probability to get 19, this is what I need to calculate. Probability to get 20, this is what I need to calculate. And probability to get 21, this is what we need to calculate. All right, okay. So here Alice stops drawing numbers when she gets k or more points. We have to return the probability that Alice has n or fewer points after that, right? Once she stops. So she is stopping at once she reach 17 or 18 or 19 or 20 or 21 or 22, 23, 24, 25, 26, but we don't need to check that. But when she's stopping, she's stopping when she reach 17, okay, then 18, then 19, 20 or 21. So we need to just calculate this part only, right? This part only. So sum of the probabilities for scores between k and n. K is nothing but 17, k and n. This is what we need to find out. Same way here, if I have 16, so I don't know there what is the value of probability to get 16, probability to reach 16. There are many ways to probability for me to reach 16. Maybe I choose 1 1 1 1 1 like this 16 times, or maybe 2 2 2 8 times, or maybe sometime 3, sometime 4, like this I reach to 16, right? After 16 I can have all these numbers, but only until 21 I have to find out, right? So this is why I'm writing like this. Okay, all right, this is clear. All right, so now here let's first discuss about this probability of 21, how I'm going to get this value. So probability of 21, this is very important part. Okay, understand it correctly without skipping anything, right? So probability of 21 I can say is equal to, maybe I am at 16, right? I am at 16, then after that I have picked one card which is nothing but 16 plus 5, right? So 16 plus 5 this. So this is one way. Okay, this output is, let's say, 1. Okay, this P16 into P5 is 1, right? Because there is only one way now. After 16, if I pick this 5, right? Only one way to do this, right? This and this card. All right. I don't know how I'm reaching here until 16, but after 16, if I have 5 now, then I will reach this 21. Okay, this is one way. Or here I can say, maybe if I am at 15, right, and here until 21 I have to reach. 21 minus 15 is nothing but 6. Okay, so after 15, maybe if I get card 6, this is one way, right? Plus maybe I am at 14. Okay, somehow I reach to this 14, and after this 14, if I pick the card 7, right, 21 minus 14, 7. Okay, this is one way to reach to 21. Or maybe if I am at 13, right, and after 13, if I pick the card number 8, then there is one possibility, right? Plus maybe I'm at 12, right, and then after that, here I pick the card 9. I can pick this 9 as well, right? Or maybe I am here probably F11. Okay, somehow I reach to this 11, and from here if I pick the card 10, this is the max card, this P10, right? 10 is the max that I can pick. So these are the ways to get this. Okay, P21, these are the different ways to get this, right? Clear? Okay, now here P5. Okay, probability to get this card out of 10. So I can say this is nothing but 1 by 10. I can say this is nothing but 1 by 10, right? 1 by 10. I can say 10 is nothing but here, my 10 is nothing but max points. So I can say that I can write it like this: 10, 1 divided by max point. Okay, 1 by max points. This P5 is nothing but 1 by m. Same way, this P6 is nothing but 1 by m. This P7 is nothing but 1 by m, right? This P8 is nothing but 1 by m. This P9 is nothing but 1 by m. This P10 is nothing but 1 by m. Clear? Right? So this is for P21, right? And here if you notice, from where I'm starting, P16. Okay, from here I'm starting. Then I'm checking P15, P14, P13, P12, P11. Okay, and I have to stop here because 10 is the max, right? I don't have 11 card, right? So I have to stop here. But here if you notice, from where I'm starting, I'm starting from 16. 16 is nothing but my K minus 1, right? K minus 1. Same way, if you want to calculate for P20, so what you are going to write for P20? For P20, you are going to write like this now. First, we have to start from 16 only. That is nothing but K minus 1. So I can say probability K minus 1, right, into, and here what I have to write? So I'm going to write 20. This is my ultimate goal, minus, and here K minus 1 I have to pass here. So K is nothing but my 17. 17 minus 1 is 16. So 20 minus 16 is nothing but 4. So 4 is what I'm going to write here. Probability to get 4 here. Same way, here this is 1. Same way here, what I'm going to write 3, and here K minus 2 now, and here P5. Okay, and then same way here P K minus 3 into P6, right? Same way here, you have to write, let's write it completely, right? P K minus 4 into P of 7. This is one way. And here P of K minus 5 into P of 8. Only 2 are pending more, right? And here K minus 2, K minus 3, K minus 4, K minus 5. Then you are going to write probability to get K minus 6 into probability of 9, and until 10 we have to stop right here. Now after this, P K minus 7 into probability to get 10, right? So now here if you notice one more thing, I can write this P4 as 1 by m only, right? This is also 1 by m, 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 and this is also 1 by m, right? And here this K minus 1 is nothing but 16. Okay, this is nothing but 15, this is nothing but 14, this is nothing but 13, this is nothing but 12, this is nothing but 11, and this is nothing but 10, right? This is 10. All right, here. So until here I'm writing P of 10. Okay, so now here, from here, one thing is clear, that I have to start from P16 always here. If you see 16 always, but for this P20, right? For P19 also I have to start from 16. For P18 also I have to start from 16. For P17 also I have to start from 16, right? So this is the end result, right? We have to find out this. So for all these 17, 18, 19, 20, 21, I am always starting from k minus 1. I am always starting from k minus 1, right? And here I'm just going to write 1 by m. Here also I'm writing 1 by m, all this stuff. All right, so I hope that this part is clear until now. Okay, same way here, one more thing. If you see here, Alice start with 0 points initially, so I can say probability to get 0 is already 1 because Alice is starting from here only, right? So this is done. So now this is one way to calculate, like if I go from 21, then I calculate this, then P20 I calculate this, then P18 I calculate, then P17, 16, 17 until I calculate like this. Or there is one more thing that I can do here. Until 21 only I need to find now, until 21. So I can store all the outputs in one array, right? So here probability to get 0, I will say that it is nothing but 1.0, right? Then what is the way to get this one? Okay, what is the way to get to this score? What is the way to get this score? What is the way to get this score? Until 21 only, right? We need. So let's say this is 21, this is 20, let's say this is 19. Okay, until here we need to calculate, right? This is one, right? So now if I ask you how I'm going to achieve this, how I'm going to achieve this probability of 1. So how I'm going to achieve this? So it's very simple now. For I want to reach to this one, right? I want to reach to this one. So definitely I have to start from previous one only, right? Here we have to start from 16 only because after 16 I can't take 17, because if I start from 17, that simply means I already reached the goal. After 17 I don't have any choices, right? Once I reach to 17, then I have to stop playing, right? So that is why I am always starting from 16 here, for 21, for 20, for 19, for 18, for 17. But for P of 1, I have to start from not 16, I have to start from previous one. Okay, this, right? P of 0, right? So probability of 1 is nothing but what is the probability to get 0, right? What is the probability to get 0, right? What is the probability, I can say, to get 0? And next time I'm going to pick one card. Okay, so that card is always going to be what, only one I can choose, right? Right, out of 1 to 10 only one I have to choose, right? So what is the probability of getting that particular card? So probability of getting that card is nothing but 1 by max points, right? Here I can say max points, right? Or here I can also write it like this. If let's say I'm here, right, I'm here, I, let's say I want to calculate probability to get I, that is nothing but this one. So here if I'm drawing the card, which card? I'm drawing card number 1, right? So I can say that I, right, here I, and here after that here I'm writing I minus j, because if I'm drawing card 1, then my remaining probability will be 0, right? So here let's say my j, let's say my j is starting from 1, I can choose 1, right? I can choose 2, I can choose 3, until 10 I can choose. Okay, so whatever card I'm choosing, so let's say first I'm choosing 1, right? So here remaining is p of 0, right? And if I'm choosing this, so divided by here, this is nothing but max points, right? Max points. So my probability of I is going to be this one, probability of I minus j divided by max points, right? So probability contribution from previous states. So this is what I'm going to get. So probability of 0 divided by max points. So this is the output for this one. Now same way if I want to calculate for probability of 2, so probability of 2 is nothing but what is the output? So probability of 2 is going to be, first let's say I pick here, instead of I want to reach to this 2, 2 is my ultimate goal. So there are two ways now. I can directly go from 0 to 2, or I can go from 1 to 2, right? These are the two possible ways, right? These are the two possible ways, right? 0 to 2 or 1 to 2, right? So here first these are the cards, right? So first let's suppose I pick 1, right? So if I'm picking 1, so probability of 2 minus 1, that is nothing from 1. Okay, and p1 divided by max points. So this is what I'm going to get. So total probability we need to find, right? So probability to reach 2 is this one, plus next time let's suppose I pick j is equal to 2, then probability of 0 divided by max points, right? So these are the two ways to reach to this. So I have to do the addition of these two now, right? I have to do the addition of these two, right? This is what we are doing now. P of 2 is nothing but p of 2, p of 2 is nothing but, here I have to say now p of 1, and here if I have p of 1, then next time I pick 1, right? Or if I have a P of 0 here, then next time I pick a P of 2 here. So these are the two ways, right? This is what I'm saying. Here first time I'm picking 1, then next time here I'm picking 2, right? So P1 and P2, probability of getting P1 is nothing but 1 by m. Probability of getting P2 is also 1 by m, max points. And here probability of 0. So until P0 how I reach, so that value, right? And here until P1 how I have reached. So this is what I have written here. So this is one way, like first I calculate P0. P0 is 1 initially, P1, then I P2, then P3, then P4, then P5. Okay, and I feed all these values. Some value I get here, some value I get here. Okay, then in the end I can simply run one loop, 17 to 21, right? I can simply run one loop, and that's when I'm going to get the result, right? Okay, and here probability of I, how I'm calculating like this, I minus j is 1 2. Here I also need to make sure few things, right? What are the few things that I need to make sure here? That this I minus j value, okay, this I minus j value, okay, if whatever I'm going to calculate here, it should always be greater than equal to 0. I don't want negative value. So this is one thing I need to make sure before executing this p of I, right? This is one thing. And also I need to make sure that my I minus j value, it should be less than k, right? It should be less than k, because I, after p of 17, if my I minus j value is equal to k, let's say, that means that probability of 17 I'm calculating. After 17, this is nothing but the way of choosing one more card. 1 into max point is nothing but the choosing other card, okay, choosing new card. But why I'm writing p17 and then choosing one card? This is not right, because after 17 I have to stop, because I already reached my k value. So that is why 1 I minus j, it should be less than k, because this one, but what does this represent? 1 by max points. This is representing nothing but picking a new card to reach to my destination, which is nothing but p1, right? From this state to next state, if I want to reach, so this is the possibility of picking the card. But why do I need to pick the card if I reach p17? I don't need to pick the card. So that is why I have to check for these two conditions. All right, this is very important part, why I'm checking this. Okay, so now let's write the code for this brute force. Okay, this is a brute force solution for this one, and this is also very important. Definitely I will get time limit exceed error. Why I'm going to get time limit exceed error? So first I'm going to check for all these values. Okay, 0 to 21, I'm calculating all this. Okay, my I is running for 0 to 21. Okay, and this n, this is n value, right? So 0 to 21, let's say. Okay, so here this is one thing. So n can be very large, 10 to the power 4, right? But in this particular example, 0 to 21, so let's say instead of 21, let's say it's a very big value. Okay, that's a 0 to n, right? Now inside this also I'm calculating the j, right? And j is running from 1 to max number of points. Okay, number of cards, I can pick 1 here, I can pick 2 here, I can pick 3 here, 4 here, right? J value. So max points is also 10 to the power 4, right? So of 10 raised to power 4 big values, okay, into of 10 raised to power 4. So definitely I will get time limit exceed error. This is not optimal solution. Let's see. Okay, but this is important to know why, how we can solve this, because this question is asked in Google, right? And definitely in the interview rounds, definitely they will ask you to first solve this problem using brute force and then optimize it. So brute force solution is also very important here. So here new double, and here you have to write n plus 1. Okay, this is done. Now here probability to get 0, right? So probability of getting score is equal to I. This is the meaning of p of I. So here p of I, what is the meaning of this p of I? Is nothing but I can say probability of getting score equal to I. All right, and here p of 0, I'm going to say 1 by 1.0, because I'm already at score 0 with probability 1, right? And then I told you to run two loops. So here int I is equal to 1, I is less than equal to n, and here I plus plus, right? So we have to check for all the possibilities. Okay, so n is 21, so 1 to 21, so I have to find out, right? And here but I have to write, how many cards I can select. I can select, let's say I can select 1, and how many total cards I can select? Z, j is less than equal to max number of points. Okay, this is the number of cards that I can choose, right? And here j plus plus, and inside this what I need to do, how I'm calculating the probability to getting score equal to I. So this is nothing but this is equal to plus equal here I have to write probability of I is equal to plus equal to probability, okay, if I'm at this position, okay, I minus j. So that simply means that I'm choosing card I minus j, right? And I'm at P I minus J, and after that I'm choosing one card. So what is the probability to get that card? So I can say into 1 divided by max point, or I can say directly divided by max points. That's it. Max, and here points. That's it. Right. So this is how I'm going to fill this. But here I have to make sure few things, that my I minus J, okay, whatever the value that I'm going to pass here, it should always be greater than equal to 0. I don't want negative value, right? And my I minus J value, it should be less than K, right? Because if my I minus J value itself is equal to K, right? So let's say P17. So after 17, why I'm choosing next card? Why I'm writing 1 divided by max points? This 1 divided by max point we are writing when we are choosing some other card, new card, right? The probability of getting new card after that, right? But we don't need to choose that. So then I don't need to check, right? So here I'm going to place this also inside this, right? So this is done. Probability continuation from previous states. So this is what I have written here. Now here, very simple code now. Sum of probabilities, okay, you can write probabilities from 4, you can say 4 scores between k and n, right? And here double result is equal to 0.0, and for int I is equal to k, I is less than equal to n, and here I plus plus, and here result is equal to result plus p of I, right? And from here you have to simply return result. That's it. So let's see if we are able to pass our test cases or not. So yes, we are able to pass all the test cases here, right? All 3. But now if I submit it, you will see that we will get time limit exceed error. So see, we are getting time limit exceed error, but we are able to pass 108 test cases out of 151, which is very good. Now we have to optimize our solution from here. So that we need to do now. But this is also very important, this optimum approach, because here you learn about these things. Okay, how I'm picking the cards, I'm checking this, right? And we have to just calculate this part here, right? All these things. So now I have to optimize my code. So how I'm going to do that? Okay, so here what you need to do now, right? So now here, if you notice one thing, okay, so let me show you here. So for p17, how you're going to calculate the values? You are going to calculate like this now, p16, right? And here p17 is the ultimate goal, right? So here you pick p of 1 then first, right? This is 1, or p of 15, and here you pick p of 2, right? This, or until when? Until let's say you get here p of 7, and here you get a p of 10, right? Until here, because 10 is the max card, right? This is your to get a probability of 17, right? Now here if I want to get a probability of 18, so here for p of 18, again I'm starting from 16 only, right? Because I don't want to start from 17, because after 17 I don't want to choose any card. So p16 here, so here I'm writing p of 1, p of 2, right? Okay, and here I'm writing p of 15, and here I'm writing p of 3, right? And same way here, probability of 6 here 6 18, right? Probability of 8 we need to write, right? Max is 10, so here 10 we need to write. Okay, here this is clear now. 16 plus 2 18, 15 plus 3 18, 8 plus 10 18, 16 plus 1 17, 15 plus 2 17, 7 by 10 17, right? Now here p of 19, if I want to calculate 17 18 19, okay, again I have to start from p16 only, right? Here, are you noticing something here? See the pattern here, what pattern, right? Here p of 16, then p of 15, and here p of 4, right? And until when? P of 19, so here p of 9 into p of 10, okay, until here. All right, so now let's try to see some pattern, right? So if this is my I value, okay, this is my I value, this is my I value, right? Same way here, let's do one thing. Let me write for p16 also, because I need to show you one thing here. For p16 we have p of 15, okay, and here I'm to start from 15, right? After 15, how I'm going to get 16? If I have 1 here, this is one way. Here if I have 14, okay, if I use this state, and here if I use 2, all right. And here until when we have to write p of 16, so here p of 6 we have, let's say, and p of 10 here. Okay, now here this is my I value, 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 right? I'm writing nothing but probability to get 18, probability to get I, right? Now here if you notice one thing, if my I value is greater than k value, right? What is my k value? K value 17. Okay, so just notice one thing. If my k value, okay, if this I value, okay, if this my I value is greater than or equal to k, right? That simply means I'm talking about this 17, 18, 19, 20, 21, all these things, right? If my I value is greater than this, then here what is happening in that case, I'm writing what? I'm writing here P16 into P1, right? This P1 is nothing but 1 by m only. This is nothing but 1 by m. Okay, all these values are 1 by m only. Whatever I'm writing here, 1 by m, 1 by m. This is also nothing but 1 by m. This is also nothing but 1 by m. Here 1 by m. Okay, let's change everything. 1 by m, 1 by m, and here also 1 by m. Here this is also 1 by m. Here also 1 by m. Here also 1 by m. Okay, for my I value, right? So if you see this P16, this is my I value, right? And this I value is less than K value, right? K is 17. So in this, I'm using P15. I'm starting from P15, right? But for all other values where my I becomes greater than equal to K, here if you see P17, I'm using P16 here, right? Here for P18 also, I'm starting from P16, right? And for P19 also, if you see, I'm starting from P16. Same way for P20, right? And same way for P21 as well. I'm starting from P16 always, right? So here I'm not using this P17 anywhere. If you see this line, right? If you see this line also, I'm not using P17 or P18, right? Same way P19, here in P20 I'm not going to use this P19. Same way in P21 also I'm not going to use P19, P18, P17, right? But here for my I value less than K, I am going to use P16 this, right? I'm going to use this value, right? This P16, see, I'm using it here, right? P16, I'm using it here, right? Okay, so that simply means what I'm going to do, I'm going to create one variable, right? And let's name that variable as current probability, okay? Something like that, you can give the name, right? So in that current probable sum, right, you are going to store the values, like what is the value for P16, what is the value for P15 every time, right? P15 and P14 for all I less than K, I'm going to use this P15 also. See here, I'm using here same way P14, right? So in P15 I'm going to use P14, right? Okay, same way here P1, okay, and here P0. P0 you already know, P0 value is going to be 1.0 initially, right? Because we are starting from here. And here if you want to write P15, how you're going to write P15? You are going to write it like this, P14, and here into P by 1, right? And here this is nothing but P by 13 into P by 2, okay? And until when we need to write, we need to write it until P5 here, okay? And here this is nothing but P by 10, right? And here all these values are nothing but 1 by m, 1 by m, 1 by m, right? Everything. Okay, so see here, this P15 I'm using P14, right? So in my current probability sum, I'm going to store all this, right? So here let's suppose if I am starting from here, right? So this value I already know, right? Now if my k itself is 0, if my k value is given as 0 only, right, then I don't need to extract any card, right? So in that case I can simply return this as my output 1.0, right? Okay, right? Otherwise we have to calculate the current probability, current probable sum, right? So how we are going to calculate this current probable sum? So first for P1, let's say I'm going to calculate P1. So P1, how I'm going to get? So what is my current probable sum? That is nothing but P by 0. Okay, how you write this? P1, P of 0, and then you extract one card, let's say P1. This is the only card you are going to extract, right? P1 I'm going to write it like this, 1 by max, points, and P0 is nothing but your current probability sum as well, right? Current probability sum, I'm starting from 0, right? So P0 is 1.0 and current probability sum is also 1.0. So I'm going to store this now. This is, I can write it like this: current probability sum, and here divided by max points, right? Okay, so here what I'm going to do, I'm going to write one if condition. If my I value is less than k, then if this is the case, then I'm going to update my current probability sum as current probability sum plus probability of I, right? So here, why I mean I less than k? Because in my current probability I'm going to add all this p14 because I'm going to use p14 here. I'm going to use p15 because I'm going to use p15 here. I'm going to add the current probability for p16 also in my variable because I'm going to use p16 here. But for p17, as soon as my I value becomes greater than equal to k, I'm not going to use this p17. So that's why I'm not going to update it to my current probability, right? So here for I is equal to 1, for I is equal to 1, your current probability value is going to become current probability sum is equal to current probability sum, that is nothing but 1.0, right? 1.0 plus what is the probability of 1? Probability of 1 you get here, right? Current probability divided by max point, so that is also nothing but 0.1, right? Current probability sum is 1.0 and max point is 10, so 1 divided by 10, 0.1. So you are going to get something like this, 1.1, right? This is for I is equal to 1. Same way you are going to calculate P2, right? Then you are going to calculate P3, P4, P5, right? And P6, P7. Then you are going to calculate P8, P9, right? And P10, let's say here. Okay, so here in this, how you write it? Let's say I'm writing 1 by m, 1 divided by m outside, and here inside this is nothing but P1, right? P1 into 1 by m, right? P1 into P1 plus P0 into P2, right? This is two ways, right? This is how you write. Okay, so 1 by m I just put outside, right? P2, how you write? P2 you write it like this, na? P1, and here also you extract P1, right? Plus here, or you are at 0 and from here you extract P1. This is how you write. Okay, P2, sorry, here, right? So I'm saying that it is nothing but 1 by m, and it is nothing but 1 by m. So 1 by m, if I put outside, I'm going to write P1 and P0. Same way here, 1 by m you have initially, let's say, and from here P of 0, and after that you extract P3, right, which is 1 by m. Or maybe you have P1 initially and then you have extracted P2, right? Or maybe you have P2 initially and then you have extracted. So this is what you need to write, right? Same way for all this you have to write. Okay, and you have to store all this p4 value in current probability in this in current probability, this in current probability, because here see p10, so I'm going to use p1 p0 here, right? Same way here for this p9 you have like this 1 by m p0 until p8 you have, right? Okay, now for p10 you have 1 by m, and here p0, p1, p2 until p9, right? Okay, now here there is one more twist that is going to come, that here if you notice how you're going to write p11, p11. Okay, so p11 you are going to get, definitely if you have 0 na, then you are not going to get directly p11. You're not going to get that, because we have only 10 cards, right? So that simply means that this time you are going to start from p1, right, and until p10, right? So now this time I have to remove this p0 right here. Now same way for p12 you are going to start from, that is why I was writing out all these things, p2, p3, and here p11, right? So only these many options you have, right? So now you have to remove p1 for this p12, right? Okay, right? So how you are going to remove this? So that is also very easy, right? So in the current probability, right, when I'm going to calculate for this one p11, how I'm going to calculate p11? P11, I'm just going to do this formula, right? Current probability sum, that is nothing but until 10, right, and divided by max point, right? This is how I calculate, right? Here if you see this formula that I've derived, current probability sum divided by max points, right? This is how I'm writing, right? But here in this current probability sum you have to reduce this p0 when you are going to calculate for p11, right? So current probability sum we are getting until p10, right? So when I'm going to calculate for p11, definitely I want to update this current probability sum before that. So I can say that my current probability sum, just update it with current probability sum, whatever the current probability sum I have, and from this subtract what is the probability at this. For p11 I have to subtract this na 0. So I can say I can write it like this: p here 10. Okay, this current probability is coming from previous, right, from here, right? So p 10 minus max score, so that is nothing but I can write it as current probability sum minus p and I minus max points, right? So I is nothing but previous 10 and max point 10, so 0. So p0 I remove, then I'm calculating for p11, right? So this is the formula that I have derived, and here I need to make sure that my I minus max points, whatever my max point, okay, when I'm applying this formula, this value, it should be greater than equal to 0, right? This value, it should be greater than equal to 0 if I don't want negative, right? So this is clear that I removed here. Now one more thing, this is clear that why we are moving, right? So here if you notice one thing here, for all these now, for this, see, for 19 here we are using until p4 until when, until p8. This is 19, right? Until p9 we are using, right? This is 9, p9. Okay, for p18, for p18 we are using until p8, right? So this one we remove, right? P8. For p18 we have to remove this p7, previous one we are removing, right? This is what I explained here, previous one, right? P12, for p12 we are removing p2, right? And same way for p17 we are removing p6 because until p7 only I need. For p18 I'm removing p7, right? For p19 I'm removing p8, right? So this is clear, this is what we are moving, right? Now here this is one condition I'm going to use, I minus max point should be greater than equal to 0. And here one more condition I'm going to use. See, whenever I'm extracting my card, right, I'm using 1 by m, okay, whenever I'm extracting my card. So here, like here if you see, I'm 18, so I'm extracting some card, right? Then I'm moving to p18, p19 I'm extracting some card, p20 I'm extracting some card, p21 I'm extracting some card behind this, right? Same way, let's suppose you reach here to p here 16, after 16 26, okay, let's say you reach here p27, right? Let's say you reach p27. So here you are going to do one thing, like uh, in p16 you can add anything to get this 27. What you are going to add? You are going to add 11? No, right? You're not going to add 11 here. That is not possible. Max point is 1 to 10 only. Definitely you are not going to do this, right? Okay, but here this is one thing that I'm saying here, that once you reach here now, once you reach to 17, you don't want to extract any more cards, right? You don't want to extract any more cards, right? Once you reach this 17, right? Once you reach 17 you don't want to extract any more cards, because from 17 you have choices like 1 to 10, but you don't want, right? Because you have to stop, right? So here what I'm going to do, I'm going to write one more condition, that my I minus max points value, it should be always be less than k. Now why I'm writing this, I minus max point less than k. All right, okay. So here if you see here, if where is the pattern here? Okay, so for p20 I'm going to use until p10 only. Okay, I'm going to use until p10 only, all the cards, right? P10, and then I have possibilities for, that means that I'm going to remove this p9 from here, right? Okay, and then for p21 I can start from 11, and then I have the possibilities, right? Okay, then that means I have to remove p10. Okay, then that simply means I have to remove p10. Okay, then here probability of 22, that simply means p12 I have to start. Okay, p12, and then from p12 I can form until 22, right? So I have to remove p11 from my previous combination, right? So same way for 23 here, if I write it shortcut, right, in shortcut manner, for 23 let's say I'm removing 13, okay, right? And for 24 I'm removing 14, for 25 I'm removing 15, right? And here for 26 I'm removing 16. Then for 27, do you want me to remove 17? That is not possible, right? Because if I reach until 17, then I have to stop. I don't want to calculate this as well, right? I don't want to calculate this, right? Okay, so what I'm going to do here, if that is the case, so I can say that my I is nothing but 27, right? And in 27, if I subtract my max points, that is nothing but 10. Okay, so I is 27, and in this my max point is this. Okay, this value, if it becomes greater than k, right? If my I is nothing but 27 minus max points, 27 minus 10 is less than k. Tell me, it is less than k. 27 minus 10 less than k. K is nothing but 6, 17, right? So no, 17 is not less than 17, right? So that is why I'm going to write this. I don't want to extract, because you may have some example like let's suppose your n is 12 given, your k value is given as you can say 2, or you can say it is given as a 1, and max point let's say it is given as 10. Okay, so here what you need to do, okay, so definitely if you are starting from 0 now, so if you pick any one card now, 1 2 3 4 5 6 7 8 9 10, so if you extract just any one card, right, so you are going to get this. Okay, you are going to reach this, right, any one out of this, if you pick any one card from this, right? So n is 12, so you may want to calculate p12 plus p11, right, then plus p10. Okay, and until when, until p1, right? Okay, so here uh there is probability of getting p1 as well, right, 1 by 10. So probability to get 10 is also 1 by 10, but after that there is no probability to get 11, p11, right? Until here we have probability, right? So which is nothing but p1.00, right? p1 to p10 we have complete hunt, we can choose any card. Okay, we can choose any card, but once we reach this once we get any score which is 1 or greater than this one, okay, k or greater than k, then there is no way to get p11 or p12, right? I don't want to check this, right? So if I want to write p11, so what I'm going to do, p11 nothing but I is 11 minus max point is 10, so I minus is less than k, that tell me 1 is less than 1, no, false. So I'm not going to execute this, okay, because I don't want to remove p1, right? I don't want to remove my p1 simply because if from 1 I can reach from 1 after p1, if I pick any card with 1 by m probability, I can definitely go to p11, right? I can 2 to 11, but I don't want now. I don't want that. I don't want to reach to this p11 because my destination is over with p1. Okay, once I get p1, my k value which is equal to k, I don't need to process further. So that is why I'm writing this condition. I minus max point is less than k. So code is very simple for this one. Okay, so here double p I'm going to use same thing, and p0 is equal to 1.0, and here double result. Okay, and this I'm going to use same, right? So now just in between we need to make some few changes, right, in this part only, that's it. So here now see carefully what I'm going to do here. So here I'm just going to write first one condition that let's suppose if my k value is equal to 0, then simply return 1.0 from here. Done. Now after that, for int I is equal to 1, I'm going to use single loop now. See the magic, what the magic I'm going to use here. I is less than equal to 1, I plus plus. Until here only, right? Now probability of I, probability of I. So current probability of I, how I'm going to calculate? So current probability of I, current probability sum, right? We haven't defined it yet. So current probability sum here, just take it as 1.0 initially, right? Because of this 0, right? So here let's say double. Okay, so p of I is equal to current probability sum, right? And here divided by max point. Okay, because after this I'm extracting any card, and to extract that is nothing but 1 by max point, right? Extracting any other card. So this is what I'm writing now. If my I value is less than k, so I'm going to use this current probability p of I, right? I'm going to use this probability of I. So if this is the case, then I'm going to operate my current probability of sum as current probability of sum plus p of I, because I'm going to use this further. But if this is not the case, but here if this is not the case, then what I have to do, current property sum, this thing is I'm always going to do, but think that my current property sum I'm going to remove the last one. Okay, so here minus p and here I, and here minus P, and here I minus, and from here max points. Okay, this is what I'm always removing, right? I minus max points. So here if you see, uh, for P2 0 to 1, for P3 0 to 2, okay, P4 same, P this same, P10, okay, P0 to P9 same, but for P11 I have to remove P0, right? Because from P1 only I can start to get numbers from 2 to 11, right? There is no use of P0, right? So if that this is the case, so I have to remove the last one, right? So here I have to make sure now that my I minus max point, it should be greater than equal to 0, right? So if my I minus max point, it should be greater than equal to 0, and I minus max point, it should be less than k. This is the condition that I'm going to give here. That's it. Okay, so this is done. So here see P10, so when this is 10, so 10 minus max point is 10, so this condition is true now, right? And I minus max point, so here this is nothing but 0, 0 is less than k is nothing but k is nothing but your 17. Yes, so yes, this is possible, right? So in that case remove it. So now if you remove P0's probability from P10, so that is the new current probability. So in P11 current probability is the updated one only, that when we are going to calculate, right? Okay, done. So this is what we need to do, and everything else will remain same here. Okay, so now let's run the code and see if there are any code issues. So try to fix that. So see, all the test cases has been accepted, right? Okay, so now if I want to create any more test case, so let's say your n is equal to 12, and here your k value, let's say it's 1, and max point is equal to, let's say, 10. All right, so now if I run it, let's see what is the output I'm going to get here. So for case 4 I'm getting 1.0. okay, now you may think that let's not use this. Okay, so let me copy this and then delete it and then run it. So now you will see the importance of this line. Okay, so now my case 4 is failed, right? All right, so this is important line. Okay, so control Z, right? Now it's submitted. So we have to stop as soon as we reach to k. Okay, so see, our solution is active, right? And for this one, time complexity is going to be of n only. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.